Hi, welcome. This is Nick Agram. I will be discussing the first or prerequisites in college algebra and trigonometry, or just plain college algebra. It's about real numbers, which is you're gonna use when you go further in your studies in algebra. Learning objectives. In this section, you will learn classify a real number as a natural, whole, integer, rational, or rational number. Perform calculations using order of operations. Use the following properties of real number: commutative, associative, distributive, inverse, and identity. Evaluate algebraic expressions, and then the last is simplify algebraic expressions. This is a representation of the sets of different numbers. The smallest one is the natural numbers. It is also called sometimes counting numbers. Why they call natural numbers? Because they come naturally. When you started to count, they will come naturally. And then bigger than the natural numbers we count is the whole numbers, and with the 0, so it is bigger. And after that is the integers. Integers includes the negative numbers, zeros, and the positive, all the counting numbers. And then bigger than integers is the rational numbers. Rational numbers, it is as long as you can put them in as a fraction, then it is a rational number. For example, we have 1/2, 15/8, for example. These are rationals. This one is 15. Maybe I will write somewhere. I'll write here. For example, 1/2, it is 0.5. Then we call this terminating. And then we have 15/8, that is 1.875. We call this terminating decimals, and both these are rational numbers. And then we have the 4/11, or 4 divided by 11, and we have 0. Or you can write this way. That means it is repeating, but it is still a rational number because you can express them as a fraction. If you cannot, then it is a rational number. That brings us to irrational numbers. Everything that you cannot express in fractions belongs to irrational numbers. Of course, irrational numbers are even bigger numbers, set of numbers. And the biggest, of course, is combining all of this is the real number. That is what we're going to talk in this video. Let's take a look some examples. For example, we have 7, which set of numbers 7 belongs. then we can say that it belongs to natural number. It also belongs to whole number. And it also belongs to integer, rational number. And many will be confused about this rational number because 7 is not expressed in fraction. But as you can see now, 7 divided by 1 is also 7. That means I can express 7 in a fraction. That is why it is also a rational number. And of course, it is a real number. I will try B. -8. Then we will say that -8 is integer, rational number, and real number. How about this one? We'll say another. How about this? -5/7, or 5 divided by 7. Then we can say that this is a rational number. If you use your calculator, I hope I have one here, -5 divided by 7. Then I will get -0 point, not comma, sorry, 0.714285714,285. As you can see, it is repeating, so you can also rational repeating number. Decimal. And then we have another example is 15 divided by 5. And this is a rational because you can express that in fraction. Then that is also a whole number. That is also an integer. And this is also a counting number, or natural number. How about 13/25? If I will multiply both numerator and denominator with 4, then I have 12/52, 100. Then I have 0.52. And that is rational number, and it is a terminating decimal. Yeah, as you can see now, there is a rational number repeating decimal. There is also rational number that you can express as a whole number if you will simplify it. And if you want, you can say whole number, rational number there. And then you can say it is a terminating also, because you can put 3.0 and it is terminating. like this one. It is 0.52. It is terminating. Let's see if we can study more about the irrational number in my next video maybe.